Hello all, welcome to our channel. In my previous videos, I have explained about a modulation and types of modulation, which are nothing but analog modulation and a digital modulation. In the previous videos, I have also explained about analog modulation techniques, which includes AM, FM and PM. So next we have another type of modulation technique, which is called as a digital modulation techniques. So in this video, I'll be explaining about digital modulation techniques along with its types. Okay. So before going into the types, we'll see what is the necessity of having a digital modulation technique. Okay. So I'll be discussing now about the necessity of digital modulation technique. So as we know, in any modulation technique, we have two types of signals, which are analog signal or a digital signal. That is a source of information, what we need to transmit, right? Okay. So in a digital modulation technique, we take a digital signal. Yes. So here we are going to transfer a digital signal and we are going to modulate the digital signal on the basis of high frequency signal, which is a carrier signal. So same modulation technique, but instead of having a analog signal as a baseband signal, here we are having a digital signal. So in a digital modulation technique, over a channel we are going to transmit a digital signal or a digital streamed data. Along with this, we are going to change the characteristics of the amplitude, frequency and phase of a carrier signal in accordance with the digital data. Yes. So digital modulation technique is a changing the characteristics of a amplitude, frequency, phase of a locally generated high frequency carrier signal in accordance with the digital data or a digital signal. Okay. So this is a necessity of digital modulation technique. Okay, just to transmit a digital signal, we are taking a digital modulation technique. Okay, so after this, we'll go for a classification of digital modulation technique. So as in the previous analog modulation technique, here also we have a different classifications of digital modulation technique. So under that we have a very basic two types in a digital modulation technique. The first one we call it as a coherent digital modulation technique, and the second one is non-coherent digital modulation technique. So naming these two techniques, we'll see now how will be the process of this coherent digital modulation technique and the non-coherent digital modulation technique. Okay. So as I told you, we are dealing with the high frequency signal every time in the case of modulation, which is called as a carrier signal. So in the coherent technique also we have a carrier which is generally generated by an oscillator. Here in a coherent technique, we need a high frequency carrier signal which must be synchronized with both the transmitter and the receiver. Okay. So here we require two locally generated carrier signals. One is with respect to the transmitter and another one is with respect to the receiver, and between these two carrier signals, what we have at a transmitter and a receiver, we need to have a synchronization. How to get this synchronization, how to achieve this synchronization? That is through the one more circuit, we call it as a phase recovery circuit or phase locked circuit. Okay. So in the coherent technique, we need to have a synchronization between the carriers of transmitter and receiver. That will be achieved through the phase recovery circuit, and that particular technique is termed as a coherent technique of digital modulation. So, coherent technique needs a phase recovery circuit. And coming to the non-coherent. In the non-coherent technique, we do not require any synchronization between the locally generated carriers of transmitter and receiver. Since we don't need any synchronization between these two types of carriers, we don't want one more addition of circuit in the second technique, that is a non-coherent technique. We do not require this phase recovery circuit or a phase locked circuit. So, we are avoiding one complete circuit in a second technique, that is a non-coherent technique. So, if we are reducing one circuit, of course, it results in a simple design of the circuit or an easy design of the circuit compared to the coherent one. So, here we have an addition of extra circuit which is called as a phase recovery circuit. Here we are not taking any phase recovery circuit, hence the reason here the design is said to be simple or easy. But the problem is there is a chance of occurrence of errors in the second technique. So, compared to the coherent technique, we are going to have a more number of errors in the non-coherent technique. So, these are the necessity of digital modulation technique and classification of digital modulation technique, which includes two types, coherent and non-coherent. So, after the classification of these two types, again in the digital modulation technique, we are changing the characteristics with respect to amplitude, frequency and phase. Based on this characteristics also, we have a different types of digital modulation techniques which are called as ASK, that is amplitude shift keying, or we can also call it as BASK. So, why B? Because every time here we are going to deal with a digital signal, and every digital signal will have only two amplitudes. One is either a 0 or another one is either a 1. Since these two values are switching between ones and zeros, we can call it as a binary amplitude shift keying, which can also be represented as BASK. So, after this amplitude, we have one more characteristic of a waveform which is called as a FSK, that is frequency shift keying, and we can also call it as BFSK, that is binary frequency shift keying. So, after this we have one more which is called as a PSK. What is PSK? Phase shift keying. So, for a binary signal, once again you can name it as a BPSK. So, based on the characteristics of carrier signal what we are changing, we can also have another subcategories in the digital modulation techniques which are called as a ASK, FSK and PSK. For every type of these techniques, we need to have two different circuits. One is with respect to how to generate an modulated signal, that is ASK, FSK, PSK signal, and another one is how to demodulate or how to recover the original signal from the ASK, FSK, PSK signal. For all these three types, we need to analyze the generation and demodulation circuits individually along with the block diagrams and the equations. Now, let us discuss the first type of digital modulation technique, that is a amplitude shift keying. So, this is treated as or considered as the simplest form of digital modulation technique. So, every time here the carrier signal will be switching between 1 and 0 value, that is it is said to be either on or off. Okay. So, here we are going to have a change in the carrier signal with respect to the incoming signal which is a digital data. So, now in order to analyze this, let us consider a carrier signal. So as we know that every carrier signal has got a high frequency. So now I am going to draw a sinusoidal high frequency carrier signal. So let it be a high frequency carrier signal. So after having a high frequency carrier signal, let us consider a digital signal, which is a incoming input signal, which will be a digital in form with the values of zeros or ones. Okay. So now I am going to have a digital signal. Either let it be having a value as 0 or 1. So let us consider two duration of 0 and 1. So let it be 0, this is 1. Again let it be 0, 0, this is 1 and 0. Okay. So I have considered the input signal as a digital signal. So now the carrier will be every time switching its action for either a 1 or 0 based on the digital incoming data. So now for 0, what will be the amplitude modulated signal? So this is a carrier, this is a input digital signal. Now I am going to draw the ASK signal, that is amplitude shift keying signal. So here I have 0 in the input signal. For 0, what will be the output of carrier? For 0, it is set to be 0 only. So here I am not going to show any waveform because the input is 0 and the amplitude modulated signal is also 0. For 1, we are going to have a high frequency carrier signal. For this duration, I am going to draw a carrier signal. For binary input 1, it is giving a amplitude as high. So after that, we have a 0, 0. So do we need to show the values here? No, not required. For a 0 input signal, so let it be 0 only. Again we are switching to 1 now. So for a 1 of input digital signal, we need to have a carrier signal, which is modulated signal. So this is a modulated signal. Yes, from this analysis, it is clear that for every high input only we are getting modulated signals of amplitude shift keying. So this is an output of amplitude shift keying. Since the amplitude shifted value is every time switching between zeros and ones, we can also call this type of amplitude shift keying as on-off keying. So instead of ASK, we can also call it as OOK, that is on-off keying. So after this, let's see how to write an output equation for this particular waveform. That is, we take output value through S of t. S of t is equal to square root of 2 into Ps, that is power with respect to the signal, that is square root of 2 into Ps into locally generated cos wave, that is a carrier wave, 2 pi fct. So every time this equation suits when we are going to transmit a value 1. Okay, and similar to that, S of t is set to be 0 in order to send a 0 value. So this equation holds good for sending a 1 value and this holds good for sending a 0 value. So this is an ASK. In ASK, we are changing the amplitude of a carrier on the basis of digital signal, and these two are the equation, and this is the waveform for ASK. As I told you, in every type we need to analyze the two circuits. That is how we are going to generate an modulated signal, and the second circuit how we are going to generate back that is a demodulated the ASK signal, how we are going to generate a ASK signal, and from the ASK signal how we are going to recover the original signal. So one is with respect to ASK and another one is with respect to recovery of original signal from ASK. So for the generation of ASK, we have a generation circuit here, that is generation of ASK amplitude shift keying. So for generation what we need? Yes, initially we need a binary digital data which is a input, right? So now I am going to take a input signal which is a binary data sequence. So generally which will be like this, which is consisting of values as zeros and ones. So after that we have a on and off level encoder. Okay, so since the values are switching between zeros and ones, every time we need to make sure that either it is leveled. So that is done through the help of encoder. So after this what we have, after the binary input, we need to multiply that input with the carrier signal. Why? Because generation is with respect to modulation. As we know that in modulation, every time we are going to have a one new signal which is a high frequency carrier signal, and there we are going to every time change the characteristic of carrier in accordance with the input data. So here, since the generation is referring to a modulation technique, we require two signals. The first one is a binary input data and the second one is a carrier signal which is given like this, that is cos 2 pi fc. So TB, it is nothing but a time duration of binary sequence what we have considered. Okay, so here in the product modulator we are multiplying the two sequences, the input and the cosine, that is a carrier signal. So these two will be multiplied and it's going to result in a amplitude shift keying. So here we are going to have a spectrum, that is a power spectral density of ASK signal which is almost same as a considered signal, but every time the power spectral density value will be slightly shifted. So since we are dealing with shifted version of amplitude, it will be slightly shifted and it is said to have a infinite bandwidth. Okay, so just for an analysis, we cannot go for an infinite bandwidth. So we have reduced that to a centralized frequency Fc, that is nothing but a carrier frequency. So this particular diagram shows us a power spectral density value or a spectrum of bandwidth with respect to amplitude shift keying. So it is just shifted with the two frequencies, upper and lower cutoffs, that is F1 and F2, F1, F2, here also F1, F2. It is said to be a symmetrical or it is a synchronized, since it is reflecting in a both positive and negative direction. So thus about the generation of ASK signal. So next what we have a demodulation of ASK signal. What is a demodulation? It is nothing but from the modulated signal, we are recovering back our original signal. Yes, what is a modulated signal in this particular technique? It is a ASK signal. So now, from the ASK, we need to extract the input binary sequence. How to get that? First, take the modulated signal. Here it is a amplitude shift keying signal. So that is the input. For this input also, we are going to have, listen, in the both transmitter and the receiver side we are going to have a carrier signal. Generation is with respect to transmitter and the receiver is dealing with a demodulation technique. So hence here also in the demodulation we are considering a locally generated carrier signal. It is a cos 2 pi fct, and between the carrier in the receiver and in the transmitter we need to have a synchronization with the phase locked system, and since we are having the synchronization along with the phase locked system, the detection is in the ASK, it's going to follow the coherent technique. Okay, so coherent detection will be done in the demodulation of ASK. So these two signals will be multiplied in the product modulator, and it has been given to a integrator circuit. See here we have a integrator. Why we are going for an integrator? And from these two multiplication, what the data we are going to get, it will be a continuous, but in the output what we require a binary data sequence which is switching its values from 0 and 1. So hence here we need to integrate the continuous pulses in order to get the sequence in the form of a pulses. So along with the integration of successive values, here we are going to do the low pass filtering operation also, that smooths out the values. That is, LPF will also done here with respect to the integrated operation. Next, it is given to a decision device. Decision device, what it gives. So here, in order to do the decision, we are going to set a threshold. So that is set here, that is threshold will be given to a decision making device. Here, based on the threshold value, it decides whether its value is 1 or its value is 0. So now let us assume that the threshold has been exceeded. If the value what we are getting out of the integrator, it has exceeded the threshold value, then we say that the output value is equal to 1. Okay, and similarly, if the output what we are getting out of an integrator is less than the threshold what we have set, then the value will be assumed to be a 0. So based on the threshold, if it exceeds the threshold, its value is 1. If it is lying inside the threshold, then its value will be taken as 0. Finally, the outcome of this demodulation technique is either a 1 or a 0. That is 1, 0, 1, 0, like that it will be continuing. So see the output, what kind of output we are getting? It is nothing but a digital output. Digital output is nothing but what? It is a input of a generation. So in a generation circuit, we are going to have a modulated signal. In the demodulation, we are going to have a original signal. So that is the difference between generating and demodulating the amplitude shift keyed values with respect to the first technique, binary amplitude shift keying or a amplitude shift keying, which can also be called as OOK, that is on off keying, since every time this value will be switching between 0 and 1. Now I am going to explain another method of digital modulation technique, which is a frequency shift keying or a binary shift keying, which is FSK. Before this, why we are moving to FSK? Because there is some drawback with respect to ASK. ASK is very sensitive to noise and it can able to handle only the lower bit data. Since it is having a less immunity to noise and it is capable of handling only a lower bit rates, we are moving to the next technique, which is a frequency shift keying. As the name itself is indicating, here the carrier frequency will be shifted to two discrete values. So as we know, in a modulation technique, we require a carrier. So here also we are taking a carrier which is of high frequency value, and the frequency of this particular carrier signal will be every time shifted based on the two discrete values. Okay, so now I'll take the bit rate switching of value for 1, that is 1. If the bit value is 1, then the output of frequency shifted keying, since 1 is a high value, we can take it as SH of t, which is equal to square root of 2 PS, that is power of a signal, into cos 2 pi FCT, it gives the carrier signal plus omega t. And after this we have a bit rate as 0, that is now 1 is being changed to 0. If it is 0, what happens? Since this 0 is a low value, you can take it as SL of t. Instead of plus, here we are changing the sign to minus. The same equation. So here it was plus. Now it has changed to minus. So these two are the frequency shifted values of the carrier signal for 1 and 0. 1 is taken as high and 0 is taken as low. If you combine these two equations, it's going to result in this particular equation. After this equation pattern, so how we are going to consider the 0th value and a 1 value in a carrier signal? I'll draw the signal now. So let us consider a carrier signal with the high frequency, that is a more number of cycles. Okay. So all the positive values which are starting from positive, that is 0 to, which are moving towards a positive axis, is taken as 1. If the value is starting from 0 and it is moving downwards toward the negative axis, then you can take it as a 0. So above the axis it is 1 and it is below the axis, it can be taken as a 0. So these are the 1 and 0 condition of frequency carrier signal. So after seeing the equation of frequency shifted keying signal, here also in the FSK we have two techniques. How to generate an FSK signal and how to recover back the original signal from the FSK signal. So in the generation, as we know, we need a input. What is our input? Input is a digital signal, since we are dealing with digital modulation techniques. So let's consider a digital signal which is usually has a binary values which are zeros and ones. It is denoted as B of t, which is a input. This B of t, that is a considered input, needs to be switched between the two values. One is 0 and another one is 1. For 1, you can take the direct value. So for the signal to be the same, what we have taken as an input, so just take the same signal. Let it be a high signal. So if it is a 1, it's going to take a 1 itself. And from the input signal, how to get the low signal? If the signal is high, it needs to be converted to low value. How to get that? Just by adding an inverter signal, you can change that to 0. That is, here in the below, we have taken a circuit which is a inverter circuit. If the signal is 1, here the same signal will be moved. It is 1, which is a high signal. If it is inverted, it's going to give you a 0. So now we got two discrete values, 1 and 0. This 1 and 0 should be leveled with the help of shifter, that is level shifter. So these two values should be leveled with the help of level shifters. So add those two values. So now these two signals should be multiplied with the product modulator along with the carrier. Yes, of course, in the transmitter and the receiver, both the ends, we require a carrier signal. So take that carrier signal from the oscillator and it is having a frequency of cos 2 pi fct. So let us take the high value as phi 1 and the low value as, you can take it as a phi 2. Okay, so high is represented with cos 2 pi fht and the low signal is represented with cos 2 pi flt. So here in the both cases, the levels will be same. So the level remains the same value, square root of ps into tb for a high value. If it is 0, it will be 0 itself. So now the signal will be multiplied through the help of product modulators, and the multiplied signals should be combined to give a frequency modulated, that is frequency shift keyed value, that is BFSK value, which is output of S of t, and that will be provided through the help of another adder. Okay, so this completes the circuit of generation. So from this circuit we are going to generate an FSK signal. By using this generated FSK signal, we need to take the original signal, which is a B of t signal or a digital signal. So how to get that? So go for an input, that is FSK signal, and this input shall be applied to a product modulator. Product modulator, again it requires a carrier. So take a two carrier signals, FC1 and FC2. Let it be given to the integrator. So why we know that? Because the frequency will be continuously shifted here. That has to be converted to regular interval successive values, that will be done through the help of integrators. So these two are the correlation circuits 1 and 2, and the outputs of this integrator will be given to a comparator. So comparator, here it acts as a decision making circuit. So comparator, if let us consider the output of this circuit as L1 and the output of the circuit as L2. If L1 is greater than L2, let us consider the output value as 1. If L1 is less than L2, then let us consider the output values as 0. So in the comparator, this decision will be done and the output will be finally in the form of our original digital signal, which consists of values 1s and 0s. If L1 is greater than L2, it is 1. If L1 is less than L2, then it is 0. So these two are the circuits used for generating an FSK and recovering a original signal from the FSK. Axis, it is 1, after FSK below the axis it can be taken as a 0. So these are the 1 and 0 condition of frequency carrier. So here also we need to after seeing what is the phase shifted keying signal and also how will be it is generated and how it is we have two techniques. How to generate an FSK signal and generally written as original signal from the FSK signal. So in the generation, as we know, we need a input. What is our input? Input is a digital signal. Since we are dealing with digital modulation techniques, and so let's consider a digital signal. Only we are usually vary the phase of a carrier, which is in accordance with the digital as B of t. So here it is a general equation. So from this you can have considered input. Different equations for switch between the two values. One is 0 and another one is
S1 of t can be written as
for
the square root of
take the direct value. So
into cos signal to be the same what we have taken as an input.
So let us consider
just take the same signal. Let it be a and the second one can be taken
so
as
it is a 1
root
going
to
to take
p1 cos
and from the input
signal
t the load
plus
signal.
theta.
If the signal
or
is
you can
high,
write theta
it needs
value
to be
also
converted
as
to low
pi
value.
because
How to
every
get
time
that? Just by adding the inverted signal, you can change that to shifted with an angle equal to
in the below
180
we have
degree,
taken
which can be either taken as 0 which is to be specific, it can be taken as a
if the signal is 1
pi is
here the same
represented
signal
as
will be
180
moved.
degree.
It is 1
in
which is the
PPSK
high
signal,
signal.
if phase
It is
of a
inverted,
carrier
it's
signal
going to
will
give
be
you
shifted
a
to
zero.
a
So now we
180
got two
degree.
discrete values,
And how to
1
take
and
the shift value in a
This
carrier
1
signal.
and 0
So
should be
I'll try to
level
draw the
signal
with
now.
the help of shifters, that is level
So
shifter.
this is an
so these two
carrier
values should
signal
be leveled with the help of level
for a
shifters.
carrier.
So add
Let
those
us
two
end
values.
the
Wave
so
at
now
this point. These
if
two
you
signals should be multiplied
start to
with the
repeat
product
from same
modulator.
side. So
Along
let
with
it be the
carrier.
signal up
Yes,
to
of
here
course,
as
the transmitter and the
from
receiver.
this
Both the
end
ends we
you
require
can
a
take
carrier
it
signal.
as
So take that carrier signal from the oscillator and
so
is
I'll
having a frequency of
take
cos
it as
2 by 0. Again the phase has
so
been
let us
shifted
take
here.
the
Here
high
also
value as
by
phi
180
1
degree.
and low
So
value
here it is
as
shifted
you can take it as
by
a
lower 180
2.
degree and here to
Okay.
the upper
So high is
180 degree
represented
value.
with
So between
cos
the 2 by
these
f
switching action
and
of
low signal
phase
is values.
values
You can take the
cos
values
2 by
of
f
carrier
and
as either
so
one
here in the
or
both
a
cases
zero.
the levels
So after
will
this
be
we have
same.
a generation
So the level
circuit
remains
for
the same value square root of
in
PS
any generating circuit
value.
as
If
we are
it is zero,
discussing from
it will be
the
zero.
ASK, FSK.
So now
Here
the signal
we
will be
require
multiplied
first
through the
input,
help
which
of
is
product
a
modulators.
binary input
And the
which
multiplied
consists
signals
of
should
zeros
be
and ones
combined to
values.
give
It has to be
frequency
given to
modulated,
level
that is
encoder.
frequency shift
The
key
level will
value,
be
that is
shifted every time. It
BFSK
needs
value,
to
which
be
is our
level
output of
with the
S of
help
t,
of
and
level
that will be
encoder.
provided
Then
through
it
the
is
help
given
of
to product
the
multiplier. Product multiplier
so this
is nothing but
complete the circuit of
does the
generation.
operation of multiplication.
So from the circuit
it takes the one more factor here for the multiplication, which is a carrier
using this
signal
generated
which can be
FSC
taken as a
signal,
carrier
we need
to
take
FCT,
the
cos
original
2
signal,
pi
which is a
FCT.
P of T
So these
signal
two
or a
will be
digital
multiplied
signal.
and we are going to
So how
get
to get that?
BPSK
So go for an input, that is
binary
FSC signal,
phase
and this
shifted
input
key
shall be applied to a product
and that particular
modulator.
value
Product
will be
modulator
now
again
needs
it
to be
requires a
carrier.
demodulated.
So take a two
So
carrier
now
signals
take this
FC1
as an
and
input
FC2.
from
Let
the
it be
signal
given to the
go back to the
integrator.
original
So why we
signal
know that?
every time
Because the
it will be
frequency will be
zeros and
continuously
ones
shifted
digital
here.
form.
That has to
So
be
in order to do
converted
that,
to
we go for a
regular
interval
BPSK as
successive
an
values
input
that
will be
after
done through the help
BPSK,
of
it has been given
integrators.
to
So
square
these
law
two are the
modulator.
correlation
So
circuits.
whatever the signal
One
we
and
got
two.
here, that
and the
will be
outputs of the
squared.
integrator
So
will
that
be
will
given
be
to a
squared
means we are going to have
So
a
comparator
signal
here
which
it
is
acts
cos
as a
square
decision making
circuit.
circuit.
So
Phase
comparator,
shifted
if
value.
let us consider the output of the circuit as L1 and the output of the circuit as L2. If
L1 is
2. So here
greater
we
than L2, consider this
let
1
us
by 2
consider
value
the output value as
DC
one
level
value.
and that
L1
DC
is
level and less than now
L2,
it is
then
given
let
to
us consider the
band
output
pass
value
filter.
as
So band pass
So in the
filter will be
comparator,
centralized
this
with a
decision
center
will be
frequency
done
of
and the output will be finally in the
So
form
in the
of
band
a
pass
original
filter we are going to
digital
have a
which
removal
consists
of
values,
the DC
ones
value
and
and it will be
zeros.
centered
If
to
L1 is
FC
greater than
value
L2
and
it is
finally
one.
it is given
If
to
L1 is
frequency
less than
divided
L2
by
then it
2
is
and
it
it's
now
zero.
divides
So these
to
two
other
circuits
C2
used
the squared
for
value
generating
to
an
cos 2
FSK
pi
and
FCT
recovering a
plus
original
theta
signal
itself
from
the
1 by 2 has
FSK.
been removed with the band pass filter and now we have a divider circuit. From the divider circuit we are able to get only the signal cos 2 pi FCT plus theta. So later it has been given to synchronized demodulator. So every time we need a synchronization with respect
Now
to
I am going to
transmitter
explain
also and that will be
another
done
method
through the
of digital
synchronized
modulation
demodulator
technique, which is
circuit
a
and now it is
frequency
given
shift
to
key or
bit
a binary
synchronization
shift
in order to
key,
have a
which is
synchronization
FSK.
between ones and zeros
Before
values.
this,
And
why
that
we are
ones and
moving
zeros
to
values
FSK
will be taken out with the help
was
of
some
integrator
drawback. So
with
this
respect
shows
to
a
ASK.
integrator
ASK
circuit.
is
This
very
combination is an
sensitive to
integrator
noise
and
in
it
order to get the
can
successive
able
values
to handle
and that
only
successive
the
values
lower
will
bit
be
datas.
taken
Since
with the help
it
of
is
two
having
switches
a
S1
less
and
immunity to
S2.
noise
So
and
once
it is capable
S1
of
will
handling
be
only a
closed
lower bit
and
rate,
S2 will be
we are moving
open
to the next
and vice
technique, which
versa.
is a
Once S2 will
frequency
be
shift key.
closed,
The
the
S1
S1
will
will
be
itself is
open.
indicating.
So based
Here
on
the switching
the
actions
carrier
of
frequency
S1
will
and
be
S2, we are
shifted
going to
to
take
a
two
digital
discrete values
output. So as
which
we
are
know in the
in
form
a
of
ones
modulation
and
technique
zeros.
we require
So all
a carrier.
these gives
So
the
here also we are
three
taking
techniques
a carrier
of
which is of high
demodulation,
frequency
that is
value and
ASK,
frequency of
FSK,
this particular
PSK
carrier signal
along
will
with
be every time
generation and
shifted
demodulation
based
of
on
all
the
the three
two
digital
discrete
modulation
values.
techniques.
Okay. So now